Okay, so let's discuss the concept of viscosity. And I want to start before we read the entire question with the first part. So it says, what factors affect viscosity? Now, viscosity is essentially the idea of how substances flow. And I mean, you know how inherently what viscosity means is how easily can something flow. If something is more viscous than if I have a higher viscosity, honey is very viscous. It flows slowly and it's very thick, whereas water flows easily, for example. So, what are the factors that influence um, viscosity? And the first factor is the strength of your intermolecular forces. And I mean, that makes sense. So if your molecules um, are more strongly interacting, so stronger intermolecular forces is going to be immediately connected to a higher viscosity. So meaning if they grab onto each other more tightly, then they will have a higher viscosity. Further factors are, of course, the shape of molecules. If they look kind of funny, if they look more like spaghetti or little marbles, then I mean, the marbles roll more easily than what spaghetti rolls. So spaghetti is going to become tangled. So, and that's literally something that they link. So if you can think about spaghetti tangling, tangling, which I link to the idea of long molecules. Long molecules. And these long molecules, because they tangle and entangle themselves, they will have a higher viscosity. Okay, so those are two things. We're looking for intermolecular forces and we're looking for strength of molecules. All right, so then we're asked, water, ethanol, ethylene glycol, and glycerol is expected, which one has the highest viscosity? And then should viscosity be affected by temperature? So let's maybe answer the last question again first. So does temperature affect T affect what do you call this thing again? Eta. I think eta is viscosity. And yes, I mean if you start boiling honey, it runs easier, more easy, right? Um, so yes, if you, for example, increase T, you give more energy for molecules and then they have more energy to overcome any intermolecular forces, keeping them from moving. So the hindrance that we just spoke about, those. So keeping them from moving forward and give them more energy, then they're moving. I mean, energy, temperature, higher temperature is more movement of molecules. So if viscosity is the measure of the movement of molecules or movement of a liquid, then yeah, then that should increase the movement. So now that we have that, what would be the order of water, ethanol, ethylene glycol, and glycerol? So if we just look at them in terms of size, ethanol is the smallest, water is the smallest, then ethanol, then ethylene glycol, and then glycerol. I mean, just looking at the pure size of the structures. And they all have hydrogen bonding present in them, and they all have then increasing length. And if you see, basically, it's water, H2O. Then ethanol has a chain, is a CH3, CH2OH. Ethylene glycol is OH, CH2, CH2OH. So there's an extra little tail. And glycerol is OH, CH2, CH, CH2, OH. So it's even bigger. So it becomes a bigger and bigger chain. So if I were to rank them, it would be water has the lowest viscosity, then ethanol, then ethylene glycol, and then glycerol. And why? So exact ranking is a bit difficult. For example, water versus ethanol, which one exactly has the stronger intermolecular forces? You'll have to do exact measurements and calculations. But for the purposes of this, we're looking at which one is bigger. Ethanol is bigger, it is longer. So we place them in increasing size. So we say they all have hydrogen bonding. So we assume they are polar, they all have hydrogen bonding. So they all have the same intermolecular forces. And because they have increasing size, it means we assume that with the size increase, the intermolecular forces are going to increase from left to right. Even though, if you think about it, I think alcohol flows easier than water. But anyway, the second thing that comes into play is the increase in length. Length or shape. Right, so those were two factors. So at the same temperature, the strength of the intermolecular forces is dependent on the size because they have the same intermolecular forces, but they are increasing in size. So the intermolecular forces will play a bigger role in the bigger molecules. And in terms of the shape, the longer ones will flow more or will flow with more difficulty. Okay, so that's how we rank them. And of course, that's what viscosity is. It's the measure of flow, the ability of flow, and what affects it. And like I said, temperature, that's how you know temperature affects it. All right. That's it for now. Thank you for watching, and I hope to see you in the next video.